assuming we are asked to differentiate from the first principle, f of x is equal to x squared. Differentiate from the first principle, f of x is equal to x squared. Now from the first principle, f prime of x equals limits as h approaches 0, f of x plus h minus f of x all by h. And so if you are given the function of x, f of x equals x squared, we are asked to differentiate from the first principle. From the first principle, f prime of x equals limit as h approaches 0, f of x plus h minus f of x all by h. And so don't forget that if f of x equals x squared, then it means that f of x plus h means that wherever you see the x term, you have to add h to the x before the exponent can take effect. Because if f of x equals x squared, then f of x plus h is, we just add h to the left hand side, and whatever you do to the left, you are doing the same thing to the right. So instead of x squared, you are now going to have x plus h before the exponent will take effect. And so f prime of x, that's the first derivative, is limit as h approaches 0. F of x plus h is now x plus h squared minus f of x, that's the question, that's x squared all by h. So f prime of x is equal to limit as h approaches 0, x plus h all squared. When you expand this, you have x squared plus 2xh plus h squared minus x squared all by h. So x squared minus x squared is gone. So when you simplify, we have limit as h approaches 0, then we have 2xh plus h squared all by h. So you see that h goes in here and we are left with 2x here, okay? So we have limit as h approaches 0, h goes in here and we are left with only 2x because the h will be gone, plus here we have h squared, so h goes in here and we are left with only 1h. Now limit as h approaches 0 means that wherever you see h in the final expression, you substitute that by 0, and so in doing that you have 2x plus 0, and 2x plus 0 is 2x. That means that f prime of x, the first derivative, is 2x. Now don't forget, if you remember the general rule for differentiation, if you have y equals ax exponent n, then dy dx will be equal to, you use the exponent to multiply the coefficient, that is na x, then you subtract 1 from the exponent. And so with the question we were given, f of x was equal to x squared. So when we say differentiate from first principle, we are talking about differentiation. So f prime of x is the same as dy dx, with the function is in terms of, is expressed as y. So dy dx, now the coefficient of the square term here is 1, so 2 times 1 will give us 2, then the variable is x, then we subtract 1 from the exponent, that's 2 minus 1. So we are going to have 2x, 2 minus 1 is 1, and x raised to the power 1 is the same as x. So the final answer is 2x. You realize that you are getting the same answer as this, okay? So you are, if you are given f of x to be x squared to differentiate from the first principle, this should be the approach. But if you are given f of x equals x squared to differentiate, you can use the general rule for differentiation, and you are supposed to get the same answer. You are supposed to get the same answer. Follow for more.